Hi, my name is Olivia, and today I'm gonna talk about self-driving truck. Do you know that driverless truck is starting rolling into our life? At this point in time, we are confronted with a significant obstacle in the process of creating, administrating, and optimizing the system for the constantly evolving product. The article will walk through the backgrounds and the rapid developments of autonomous trucks and how the self-driving truck system is trying to integrate into the existing system we are living right now in a couple different aspects. Primarily, it is critical for us to understand why the world we live in today requires the incorporation of auto truck system into existing systems. So, what is autonomous truck? Autonomous trucks are commercial vehicles that use AI to automate everything from shipping yard operation to long-haul deliveries. This technology uses long-range, high-resolution sensors and a range of deep neural networks and high performance energy efficiency compute to improve safety and efficiency for everyday logistics. So, why we need self-driving truck? These intelligent trucks may be the first autonomous vehicle to access public roads at a scale contribute to the industry factors such as increased delivery demands and driver shortage, as well as straightforward operating domains such as motorways. As transportation business seek to autonomous technology to keep up with expanding demands, driverless trucks are hitting the road. Finding the most efficient approach to transfer control trailers from machine to people is currently our top priority. According to the American Trucking Association, there will be shortage of 80,000 truckers approximately by 2022. Experts predict that the trucking business will require more than 160,000 operators by 2030 if the current pattern continues. Not just the pandemic, but both the supply chain crisis and the truck driver scarcity are all contributing to significant delivery bottlenecks. The fact that the trucking industry is struggling through a driver shortage has increased the levels of interest in vehicles that are empowered with artificial intelligence and have the ability to drive themselves. The owners and the executive of motor carrier recognize that there is untapped potential to increase the operational efficiency, safety, and productivity of their business. For years, various platforms have been putting self-driving trucks through their pace in the real world. Though humans currently occupy the driver's seat, experts predict that by 2023, automobiles will be fully driverless. The goal for the autonomous truck is to do what is called the middle miles in logistics. And this means getting online order from a fulfillment center to store and pickup location instead of making long distance trips to get product from the factory to the warehouse or to people's homes. Driverless truck technology classification. So now the question then becomes what levels of autonomy can be adopted in commercial vehicles and when should each be adopted. The current state of federal policy and regulation for the autonomous trucking market are largely absent, making integration across fuel network difficult. Let's see what levels are in self-driving truck now. This change includes small shift towards increased driver assistance. In many cases, these technologies can be seen in both passenger vehicles and heavy-duty trucking on the road today for the level 1 and level 2. In level 1, for instance, can handle adaptive cruise control and lane assist features. Technology at level 1, however, is implementing independently of other autonomous features. Level 2 involves two primary control functions working together. Leading edge companies such as Peloton and Tesla have implemented these levels of automation in prototype fleets. Level 3 is where automation starts to become more intensive. Fully autonomous solutions begin to emerge in instances where highway driving is consistent and predictable, like long-haul routes. The drivers choose which automated feature to employ, and most miles are traveled autonomously. But the driver maintains ultimate control of the vehicle throughout the whole drive. For example, where driver intervention is required include extremely bad weather, events that limit connectivity and visibility. If it's pouring rain, it's difficult for the camera to see and to find the best way to go. And then more variable urban and city driving that require frequent stopping and starting that actually is not a fully perfect situation for autonomous truck to run right now. So level 4 automation is similar to level 3 in that the driver is still need to be present. But at this level, the vehicle will be operating fully on its own in all scenarios. Most companies are jumping level 3 and striving for level 4 right now. For example, Waymo is studying level 4 technology within their own business but have yet to move into commercial sphere. Too Simple, founded in 2015, is another market leader that is testing automated vehicle at the higher levels of automation. Too Simple operates 200 trucks in the United States and 500 global trucks over millions of miles of testing throughout 2019. Level 5 is perhaps the furthest from the reality of today's trucking industry. Humans would no longer be driving trucks or even present, and vehicles will be fully automated. Level 5 automation is more prevalent overseas, specifically in Sweden, where two companies in Rise and Volvo are testing level 5 technology in control, low speed, short distance environments. So with the rapid developments of the autonomous truck, there are already good news about autonomous trucks on the internet now. So in June 2021, Too Simple, the company based in San Diego, is conducting supervised autonomy test runs in Arizona and Texas in partnership with Navista and UPS. The supervision includes someone riding in the cab in case they need to take the wheel. March 2022, during the course of more than 5 consecutive days, a self-driving 18-wheeler transported goods between the cities of Dallas and Atlanta. Operating nonstop for 24 hours, lodging over 63,000 miles travel, completing 4 circuits and transporting 8 separate loads of cargo. In June 2022, in U.S. pilot program, there are some autonomous trucks have already driven on public highways. This test vehicle either have a safety driver in the cab to take over in case of problem or were followed by a mobile assistant. In August 2022, on a Wednesday night in August, a purple and white truck left a suburban grocery store and drove 7 kilometers to the Low Block Coast Ltd, headquartered in Brampton, Ontario, which is west of Toronto. So now we're going to talk about concept development stage for the autonomous truck to integrate into the transportation system we have right now. So this stage question and answer the need for new or a replacement system involved, analyzing the planning, the new input system and its feasibility. Thus, this requires to take into consideration various factors such as stockholders' needs, practical feasibility, budget cost, scalability, and etc. Since this is an initial stage of the system engineering development life cycle, it is very different from the rest of the stage. It also involves understanding of the interaction between the system and the external environment and the internal interaction. System engineers helped in converting operational need into an economically and technically viable solution. Concept development further can be classified into 3 substages. The first stage is we need analysis, a system study, technology assessment, operation analysis. And next step, we need to do the concept exploration. It requires analysis, concept synthesis, feasibility is an experiment. And the next step is going to be concept definition. So we will understand the concept and the viewpoints of establishing self-driving truck into our transportation system. The concept development stage of self-driving truck and for any system engineering project will provide valuable information needed to carry out the corresponding parts of the system engineering life cycle. So the primary objective of need analysis is to show that there's a valid operational need as well as strong and open market for autonomous truck. So we must analyze the pros and cons the system offer with respect to its predecessor and need to be fully aware whether the system bring any value within a budget and a few threshold. From the analysis, we can see that due to industry pressure from rising delivery demands and driver shortage, as well as straightforward operational domains such as highway, these intelligent trucks may be the first autonomous vehicle to hit public roads at scale. In the very beginning development stage of autonomous driving, it has assisted vehicle driver and passenger as one of its final mission. For example, collision avoidance, stability control, and lane departure warning system that developed and cooperated with autonomous driving technology today, which are very helpful for the truck driver and turn the driving large vehicle to be much safer. Compared with the ordinary auto driving system, auto driving technology of truck could be capable of preventing any harmful driving behavior, including speeding and effective driving. It is possible that the road traffic safety will be improved to some extent when these autonomous driving technologies are popularized. Although autonomous driving technology still has its limits and it could hardly prevent accident under certain circumstances involving the specific weather and road condition. However, many system engineers state that the autonomous truck will greatly reduce accident compared with a manually driven trucks. According to the report released by the McKinsey Global Institute, autonomous driving technology is expected to reduce traffic accident mortality by approximately 90%. So the results of concept need analysis is a stage of get carried over into the concept exploration stage. Every step of system engineering is necessary for this transformation from a purely operational to purely technical perspective on the system. This step involves giving the user a wide variety of options to choose from, and the abstract notion that can be developed into a concrete representation of the system. In order to bring self-driving truck from the concept stage into actual work, a number of infrastructure and functional modules are required. System engineers need to break the process of concept exploration into four distant steps in order to bring the concept of driverless trucks one step closer to the reality. There are various requirements we need, so such as in-depth to analyze our operational and performance requirement, and a well-designed new system or model. What is more, a technology-driven system is created by a system developer who is knowledgeable about the technology would be the most ideal. So for the aspects of self-driving truck for concept exploration, first of all, it takes an important place for system engineer to quickly determine the need for software and hardware infrastructure with sensor by first conducting an operating requirement analysis and a performance requirement formulation. Next, hardware infrastructure like LiDAR, GPS, receivers, and onboard computers, for example, could be quite helpful in bringing the overall project to a successful conclusion. Then the navigation process initiates the use of software that can not only simulate autonomous driving condition, locate the vehicle using sensor data, but also implement control algorithm. Additionally, system engineer will examine the implementation of concept exploration to determine how to assemble the necessary software and hardware infrastructure could be seen as subsystem of component. There's also a need to investigate a wide variety of possible technology and architecture implementation to guarantee the smooth operation of all the subsystem and component. The concept of expiration phase will be complete when performance requirement validation has been carried out. So it is necessary to create a series of tests and a list of requirements for autonomous truck as research into performance requirement validation. One more important element for this process is to verify the applicability and compatibility of autonomous truck system. System engineers need to check the condition of this infrastructure and functional module on a case-by-case and module-by-module basis to get the correct report. Therefore, by learning about concept exploration, we can get a firmer grasp on autonomous truck and their inner workings. So for the concept definition, system engineer will have to think about the several issues they will probably meet when the engineers are designing and building the autonomous truck. Due to several objectivity aspects, including the operational performance, program cost, and schedule conflict, trade-off would be a reasonable option for us. Furthermore, risk is another significant aspect, which will be taken into consideration. Moreover, system engineer would use two tools involving test and feedback to improve the autonomous truck. Except these two tools that test and feedback. Measurement, observation, estimation will be used to have developed and validate the autonomous truck as well. So this phrase not just entails selecting from alternative system concept describing concept exploration as the basics for the future research in engineering. But this phrase also begin work on the new system functional and physical aspect that used for system developments on the ground. Multiple case study must be undertaken to determine the best option depending on operation performance and compatibility and program budget, program timeline, risks. So now let's discuss all these factors in detail. When designing and building the self-driving truck, engineers need to give some thought to the various problems and might encounter in process. The operation compatibility, the cost of the program, and the schedule conflict are all objective factors that need us to make a trade-off. Another major factor that will be considered is the potential harm will occur in the development. There are lots of options available such as measurement, observation, and estimation will be used to build and test the drive of this truck. Despite the safety, autonomous truck is able to be improved by using two tools involving test and feedback. The importance of safety cannot be overstated. Engineers should hold ourselves to each other to the highest safety standard in trucking. Whether it's running in simulation, testing the hardware and software, or putting the trucks out on the road, this standard applies regardless of whether the trucks are self-driving or not. So there's also lots of challenging when we try to developing the autonomous truck. There's still a long road to drive this truck, although there already have some breakthrough news all through the internet. For example, self-driving in some states such as California and Texas it is now legal for 18-wheeler to drive on highway. On the other hand, there are still human safety drivers operating the vehicle. What would it take to get them out? Developing an autonomous driving system is difficult enough. Integrating it into current vehicle platform is another. And deploying such vehicle in the real world in a way that is both commercially viable and safe is yet another obstacle. Needless to say that the testing and operating autonomous vehicle in today's world are severely hampered by a hodgepodge of restrictions imposed by individual states. Every state transportation law can be very different from state to state. What is more, deploying these trucks is also It's also a logistical change that will call for significant change to be made throughout the trucking industry as a whole. From the news we mentioned earlier in the background section, Corey's Trucking did not enter either city during its delivery service between Dallas and Atlanta. It started the highway at it exited the highway at convenient location to drop off its loads and fuel up with fuel before heading back. After that, regular delivery trucks picked up the goods and completed the final or last mile of the journeys. First, business must establish a system for these transfer hubs in order to implement widespread deployments of autonomous trucks. However, it is really expensive to build this kind of infrastructure, the transfer hub for autonomous truck from scratch. The self-driving truck company are seeking the ways of working with the existing infrastructure. Getting this truck out on the road without a driver is the next biggest challenge in the quest to automate the freight delivery. Businesses like Korea understand that fully autonomous trucks are still years away. Therefore, they are trying to find ways to use autonomous trucks only in highway, where the traffic is less congested and the roads are wider and straighter, making them more suitable for deployment. Although this plan is sensible, it still needs years of refinement. Technology challenges exits. Despite self-driving trucks are able to take care of majority of the events that are taking place in the highway, companies are still working to guarantee the self-driving trucks can respond to some unconventional situation. Thank you for listening.